Hello everyone. I am Veysel Turan Yılmaz from Turkey. I am a chemist and working at Karadeniz Technical University at Trabzon. Trabzon is a beautiful and historic city located on the Black Sea coast. I lead a research group working on the synthesis, structural characterization, and biological activities of novel metal complexes. In this context, we prepared a wide range of silver complexes and investigated their antimicrobial activities. Let me give you some information about silver and its metal complexes and also their antimicrobial activities. As you may know, metallic silver has been known to exhibit antimicrobial properties for centuries. Although the mechanism of action of silver is not yet fully understood, its antimicrobial activity has been shown to be closely related to the interaction of silver ions with the diol group of membrane proteins and silver-associated DNA and RNA damage in microorganisms. In addition, aqueous solutions of silver nitrate have been found to be effective against many microorganisms, but their use has declined because of the accumulation of silver in the skin and also other tissues. Moreover, these solutions are not stable when exposed to light. Silver sulfadiazine is a polymeric silver complex and exhibits a broad spectrum of antimicrobial action. It was first approved by FDA as an antimicrobial drug. The discovery of silver sulfadiazine has led to increased interest in the design of new antimicrobial silver complexes. In this presentation, I would like to explain synthesis, characterization, and crystal structure of a polymeric silver nitrate complex containing 1,2-bis-4-pyridyl ethane. In fact, the complex was designed and synthesized to study its antimicrobial properties against various pathogens. However, very low solubility of the complex avoided us to test its antimicrobial activity. This complex actually was prepared by the reaction of silver nitrate and 1,2-bis-4-pyridyl ethane in aqueous solution, and we obtained its colorless crystals at room temperature after a few days. We observed that the tidal complex is both air and light stable. The silver complex was characterized by elemental analysis and also common spectroscopic techniques, including IR, NMR, and mass spectroscopies. In addition, the structure of the complex was also determined by single crystal X-ray diffraction. Here we only present details of the crystal structure and structural data. If you look at the table 1, you will see details of data collection and structure refinement of this complex. X-ray measurements show that the silver complex crystallized in monoclinic crystal system. Although the crystal quality is not good, the refinement parameters were fine. As shown in figure 1a, the silver bond ions were bridged by 1,2-bis-4 pyrityl ethane ligands through the pyridine nitrogens, and this forms a one-dimensional coordination polymer running along the crystallographic axis A. Yes, you can see here a part of the chain. The coordination environment around silver ions seems to be linear with the N silver and bond angle of approximately 172 degrees. However, the distance between silver one ion and one of the nitrogen of the nitrite ion is only 2.75 angstrom, which is an important distance to say that there is an interaction between the nitrite ion and silver ions. We call this a semi-coordination of the nitrite ion with the silver ion. This semi-coordination explains the deviation of the N silver and bond angle from the ideal linear angle of 100 degrees. In this case, the coordination geometry around silver may be considered as T-shaped. As shown in figure 1b, the individual chains are connected by electrostatic contacts into a two-dimensional layers running in the AB plane. Here, I explained the crystallographic measurements and structural data of a new coordination polymer formed by silver and 1,2-bis-4 pyrityl ethane. We don't show the characterization data here, and that's all. Thank you for your patience and best wishes from Trabzon.